Are you struggling to debug your AWS microservices? Let me show you how to use AWS X-Ray to trace your Node.js Lambda functions and microservices. By the end of this video, you will know how to trace AWS services to different service calls like S3, SQS, SES, and you will understand how requests flow across your microservices, identify performance bottlenecks, and fix them fast. You'll be able to look through your entire request journey, your entire request flow, moving across different services, estimating successes and failures through the way. You will check in the request how each function behaves and how it resolves. You will have fine-grained control and fine-grained observability over the client request journey. So let's talk about AWS X-Ray and what it does. So X-Ray collects data about requests passing through your app, provides a detailed trace map with information like latency, error, and dependencies. It captures HTTP requests, AWS service calls, and downstream services. And the importance of this, that it debugs complex microservices architecture. It also identifies performance bottlenecks and reduces downtime and failures. Okay, so let me show you how to enable it step by step. So taking a Node.js application as an example. So our application is a blog post where users can create their posts and share, subscribes, and likes others' posts. So this is our microservices architecture. So we have the API gateway here. The API gateway invoke the HTTP request to the Lambda function, and the application Lambda function then can create or make CRUD operations to the database, and it can store images and so on in the S3 bucket, and the S3 bucket itself can moderate its content through the AWS Amazon Recognition Service. And also we have the application Lambda send queues to an Amazon SQS, and this SQS actually stores messages in the queue to notify subscribers when the blogger that they are subscribed to creates a new post. So the events queue Lambda receives the messages from the SQS and notify these subscribers via Amazon SES email service to notify about their blogger messages. Okay, this is briefly our application. Okay, so for the demonstration of the X-Ray tracing, we need to trace the create post request journey. So we need to trace when a user creates a request, when this request hits the Lambda function, the application Lambda function, when this request stores the image in the S3 bucket, when the S3 bucket is being moderated by the Amazon recognition, and when also the post got saved in the database, and then how this newly created post will be sent to the SQS queue and got received by the event queue Lambda and then sent to the email service. So I'm very excited, guys, to show you how we can trace these microservices. So let's start. So here I'm using AWS SAM templates. So AWS SAM is a perfect service that makes you manage and deploy your serverless applications. So these are our template for the application. So let's quickly skim through our AWS SAM template. So we have the S3 bucket here, and we have the main Lambda function, the main application Lambda function with the required access policies, so the Lambda or the database or the SNS with the different access policies. And also we have the security groups and so on. Okay, and there is the API gateway. Okay, so let's start with the point and integrate our application with the X-Ray. So first, we need to add the tracing configuration to the AWS template. So we'll find all our Lambda functions. We have 3 Lambda functions. As we've said, we have the one for the main application and one for the queue and the last one for the scheduling. So we have here our main Lambda function, and then we will also get our rest of our main Lambda function. And also we'll get the other 2 Lambda functions. We have the SQS Lambda handler and the notification handler. Okay, so let's start now. So each Lambda function, we need to add tracing active here. We need to add tracing active. And the other thing is that we need to add policy to allow the X-Ray to take the debugging and the tracing information. So we need to add this part here. We have to add here this part, okay, to allow the X-Ray to take the information from the Lambda functions, okay? So we just copy and paste this part, we'll be good to go. Okay, so after this, let's install our required dependencies. So of course, we already have the AWS SDK here. So now we need to install the AWS X-Ray. So we'll go with npm install AWS X-Ray SDK. Okay, perfect. So I already installed it, so let's move on. So for us to enable the X-Ray for the HTTPS requests, we need to add this code. Okay, so we're capturing all HTTP and HTTPS requests, and then we'll add an X-Ray main segment for each request here. And after the request is being done here, we will actually close the segment. Okay, so this is the first thing that we need to do. So after that, we will check our create post. So we'll go to the post, create post, then the services, post services. Okay, so here we have the create post. So for the create post here, what we need to do is that we will import the X-Ray AWS SDK, which is already imported. Perfect. Okay, so after this, we will define the X-Ray AWS constant. Okay, perfect. And the capture AWS here actually makes the X-Ray trace all the services that are being invoked by the AWS SDK in the application. Then what we need to do is to track this function. So we already have a main segment or a parent segment, which the one that we have defined in the app.ts. So now we need to make a subsegment for this function. Okay, so now we will get the parent segment here. So the segment, so this is the parent segment here. We will create a high level subsegment for this function for the business logic here. What we need to do here is that we will actually wrap all the business logic here, this part, the business logic here, we'll wrap it all into X-Ray so that it can be all traced by the X-Ray. So let me show you how we're going to do this. So I'm going to say return AWS X-Ray dot capture a sync function, as simple as this. So we'll create here the subsegment post. So then we'll say, okay. So then we will say sync, and then here we should take the subsegment in the callback parameter here. So after this, we're going to have all our application function. Perfect. This is perfect. So first we need to check to confirm that this subsegment is not undefined. Perfect. And then what we will do is that we need to define that this subsegment is actually in the same space as the parent segment. So what I mean by this is that we have a variable called namespace. So the namespace is either remote or local namespace. When a subsegment namespace is local, it's actually gonna be within the same parent segment. But if we define the namespace as a remote, it's gonna be in the map treated as a separate node. So actually, let me try to tell you what I mean by this. So looking into the difference between remote and local namespaces. So what we have here is that if I define a node as a remote, it will be a separate node like this. Okay. But if I define a node like but if I defined a subsegment that it's a local subsegment, so it's going to be wrapped into the main subsegment here. So actually our main segment here, which is Awesome Block API, is actually our main segment here. So this is a segment. Okay. So I hope it is clear now. So we have our main segment, and we will define the subsegment as local, because if we define the subsegment as remote, it will be a separate node here. And we don't need to treat this as a separate node, actually. Okay. So in short, we'll define the namespace as local here. So we will set the subsegment namespace as local. So let's continue. So here we're verifying the user existence. So if the user do not exist, we actually in this case need to add something called annotation. And the annotation here, as we will see, is something that we can filter with later on while we are debugging. So we can have here two annotations. We can add annotation success false and user found false. So let's continue. So after we pass this section, we can add like another annotation, which is subsegment user found true and user ID perfect. Okay, so what we need to do now is that we need to create something that is called a nested subsegment. So we'll create a subsegment for the subsegment. What our current subsegment? So our current subsegment is create post, and we'll create a nested subsegment.